Everyone to another ChronoLogic live stream. This week is about execution markets, and we have Logan, our resident expert about execution markets. He's going to give us the latest development updates. Welcome, Logan.
Hey, thanks guys for coming out. So this presentation will be on the execution markets. It's a preview on the same talk that I'm giving later this week at DappCon. So we'll get into that a bit later, but before we do, we'll start with the development updates, and we have quite a few this time around. So one of the big things we've been working on is the Melonport integration with Chronos. So we submitted a second MIP to their repository. This is a fuller spec about what the integration will look like. So if you're curious about the work we're doing along these lines, I highly recommend you visit this link here. It's our second issue that we've opened for the MIPs. So we're working toward this. As well, one of our developers, Daniel, put together a test repository. So this is a proof of concept that shows the Chronos validator with the Melonport integration, and then has some tests to show that it is functional and working. We also have updates to the token allocator. So this was mainly things to do with the vesting functionality. We added in 2 versions to make it compatible with the vesting wallets and the vesting tokens that we know of. And then we have updates to the DApp as well, such as the analytics. Before, if they were unavailable, you wouldn't know because it wouldn't show anything. But now if you have it turned off, we'll go ahead and display a message for you. And we also have the DAI and the day token transfers integrated natively into the DApp, currently in the develop branch. So not quite released yet, but if you pull down the develop branch and run the DApp locally, you'll be able to access a drop-down menu, which will let you select both DAI and day tokens to schedule a transaction to send those.
That's pretty cool, Logan. Someone from the community has a question. What does MIP stand for?
Oh yeah, sure. So the MIP, it's Melonport Improvement Protocol.
Okay.
It's similar to the EIPs, the Ethereum Improvement Protocols, but it's Melonport specific.
And is all the work that you guys are doing on the 0x protocol, is that what they use at Melonport?
So that's the exchange that we've been targeting, because we think that's going to have the largest network effects with
Right.
the 0x relayers. So Melonport uses 0x for the exchange functionality. It also uses DEXI, for example, and I think they have a adapter for other exchanges too. But as far as what we've been targeting the 0x protocol.
Yeah. My understanding is that a lot of the decentralized exchanges use the 0x protocol. So the development you guys are doing with Melonport, with the conditional stop loss and everything, could be applied to a lot of other exchanges in the future. Is that right?
Yeah, that's correct. So that's worth mentioning actually is so as we've been developing these MIPs, we've been doing a lot of research into 0x as well, and we're trying to keep ahead of the curve on keeping Chronos compatible with the 0x protocol, as well as working on this integration with Melonport. So we've been kind of doing on both fronts there.
Yeah, really looking forward. I have a question about the DAI stablecoin. So that's not quite released yet. It's in the develop branch. but once that's released and once we go to mainnet and everything, people can just select DAI, which is an ERC20 stablecoin, like from a drop down, and then they can schedule that like a year from now and not have to worry about volatility. Is that right?
Yeah, so that's a really cool thing about using DAI in a scheduled transaction is that you have confidence that the DAI will be worth the same value today as it will be worth a year from now or 10 years from now because it's pegged to the USD. So one DAI always equals one US dollar.
Great, very good.
So we also have some updates on the research side as well. Piotr posted an article earlier today about the gas price mechanism. So we're doing some, we're looking a little bit deeper into some of the stuff with the EAC as we're getting closer to the mainnet deployment. And this article shows some of our thinking with the gas price mechanism as far as it goes with how the time nodes will set the gas price for executions. So if you're curious um, into learning more about that, you should read this article. It's available on the ChronoLogic blog. And I also posted an article earlier today as well. It's kind of a companion piece to the talk I will be giving at DappCon and the presentation I'll be previewing tonight. So it's about execution markets, which is a kind of generalized pattern that we've been noticing as we've been working on the time nodes, as well as what some other projects could use the execution clients for as well. So this kind of goes into like a big picture uh, as far as the execution market goes with the time nodes or other execution clients. And so I'll be going into some of that right now, actually. But before that, I want to just let everybody know that we're present at DappCon. A few of us from the team are uh, already in Berlin. So DappCon is a conference for Ethereum dApps. Some of the uh, projects are attending. The organizers are Gnosis, and we're super excited to be a part of it.
Yeah, and you guys are already at the co-working space in Berlin where Gnosis is headquartered, and you're having all these like secret meetings and conferences with other projects. Are you picking up a lot of interest about these execution clients and the monitoring watchtower stuff for all these applications like the scaling solutions?
Yeah, I mean, we'll see. We'll be able to judge the excitement and the interest a little bit more after I give my talk on Thursday morning. So it's one of the first talks of the conference. So I'll be able to get a little bit more feedback from everyone at that point.
Great.
But
A lot of big names are there, right?
yes, yes, a lot of the DApp projects are here, including Melonport, uh, and including MakerDAO for the MakerDAO are the ones who created the DAI stablecoin, so
Right.
they're here as well. So it's a great opportunity for us to network with the other projects and of course get the word out about our own project as well.
Great.
And just a quick mention, there is going to be a live stream. We'll post the link to the live stream in the Telegram channel as soon as we have that. It'll be my talk is on Thursday morning, and the conference is on both Thursday and Friday.
Perfect.
So we'll keep everyone updated in the community. All right, and so so we can go into the preview of the presentation I'll be giving. So the topic is execution markets, and let's go into it. So this idea of execution markets is something that we've been noticing as an emerging pattern from our own projects with the EAC and Chronos and the idea of time nodes, as well as some other projects in the space. We've been seeing that there's this need for delegated execution. So to signal an execution from a user and to allow a third party to actually send that execution to the blockchain. So in the EAC and Chronos, for example, we have the scheduled transactions, which will later be executed. But there's also other abstractions as well, which I'll go into on another slide. But one of the interesting properties about the execution market is how similar some of the notions are with the Ethereum gas market. And we're seeing kind of a recreation of the gas market as a layer two uh, execution market, essentially. So instead of paying for your transaction, you're paying someone else to pay for your transaction.
Mm-hmm. Yeah, that makes sense.
So some examples of projects that need execution markets. We of course have the projects that we're working on at ChronoLogic, the EAC, the Ethereum Alarm Clock, and Chronos. These are applications to schedule transactions. But we also see other projects in the space, such as transaction relayers. So these are ways for a user to sign a message for their transaction, and then to give this signed message to a third party, and that third party will relay or essentially execute the transaction on chain. And the purpose of this varies, but some of the reasons could include new user onboarding, for example. So if your application wants to bring in new users, but you expect these users to be new to crypto in general and not to have any ether, you can work this scheme in where you're uh, essentially covering the gas costs for their
Right.
executions. That way you can have a higher growth rate or bring in new
Mm-hmm.
users or uh, whatever other purpose you are using this for. And then there's a really good EIP, which we can't take credit for, but another member of the Ethereum community, Alex Van de Sande, uh, published this, and it's a standard for these signed messages. And the kind of stance he takes on it is to pay for gas using tokens instead. So instead of using Ether to cover your gas costs, you can similarly as the transaction relays, sign a message, give this to a third party, and then uh, instead of paying for Ether, you send the third party tokens instead. And this is all accomplished with a smart contract that he details in this EIP proposal.
It's a pretty cool
And
concept.
super cool, super cool. And it's definitely inspiring some of the work we're doing with Kronos as well. Uh, and another application that uses the idea of execution markets. This one's kind of surprising, but there's a ZK Snark mixing contract called Miximus, and the idea is that you send one ether to this contract, and you create a zero knowledge proof, and then from a and then you generate a new contract. I mean, sorry, you generate a new address that has no ties at all to the other address that you use to send the Ether. And then you can publish the zero knowledge proof on chain, and the Ether will get sent to this newly generated address, and uh, there's no connection between these two addresses, but you send Ether between them. So this is known as mixing Ether or
Mhm.
anonymizing your Ether.
Yeah, and anonymity is a huge thing. There's so many of the biggest cap tokens in the crypto world are focused on anonymity. So if these types of execution clients can play a role in anonymity, that's a pretty big market.
hmm Yeah, so so it basically takes the same technology uh, that makes Zcash work, and it applies it on top of Ethereum as an Ethereum smart contract. So it's a super interesting application, and the way that execution markets fit into this is that the newly generated address, so it's an address without any ether in it. It so you need to publish this zero knowledge proof on chain to send ether to this newly generated address, but you can't publish that proof without ether because you need to pay the gas cost. So the execution market comes into play because you can uh, send this proof to a third party executor, something similar to a time node, and then that time node will execute that proof on chain and mix the ether on your behalf. And then you have true anonymity because you don't ever have any you don't have to send ether to the new address, so there's no way to link that new address to uh, to that proof. So
Right, right.
um, and then um, and then these are a little bit different. And I'm still learning about these actually the state channels and the watchtowers. They're somewhat similar to executors, but they're a little different because they have a they're a little bit more so they're more I guess known. So like when you open up a transaction with a watchtower, you're kind of picking that watchtower, and that watchtower is then executing on your behalf. But it's a little bit different from these other ones because these other ones imply a a network of unknown decentralized nodes, while the watchtower is a known node that is working on your behalf. But
Right.
still, it's a similar concept, so we're keeping it in mind as we move forward. So I'll talk about some examples, and I'll use our projects from ChronoLogic to illustrate these. So on the left, I have the flow of the Ethereum alarm clock. So what's happening off chain is a user is sending the user is off chain, sending a transaction on chain to the Ethereum alarm clock. That's deploying the scheduled transaction. And then the executor, uh, also known as the time node, is watching the contracts and so knows when the new contract is deployed. And then when that contract hits the execution window, the time node sends the execution transaction. So that's how the EAC works. The executor in this situation is a time node. Um, on the right hand side, I have the off chain control flow. So this is what we're working into the POC, the second POC of Chronos. So POC 2, um, we basically just got the code in there last week, but is it allows for off-chain scheduling. So it's a pretty cool change. But the way it works is that the user who is off-chain signs a message and keeps that off-chain. And for anybody listening that doesn't know what signing a message means, so it means you use your private key to approve a message, and in this case, the message will be a scheduled transaction. So you can use your same Ethereum private key to sign uh, any data, and then you have the same. Then you can verify that that data is approved.
Right.
So you sign the message, you publish this still off chain to the TimeNodes, the execution network, and then only after uh, all of this happens and it's ready to be executed does it ever hit the chain. And the time node will send the execution to a proxy. Here it's called a proxy contract, but it will be the Chronos kind of central like proxy contract, and then uh, that forwards your scheduled transaction. And because it's signed by you, you know that the transaction is the same data that you signed, and the contract checks that the signature is valid and all that.
So Logan, what are some of the advantages and disadvantages to on-chain versus off-chain scheduling?
So the advantage of off-chain scheduling is that you can save a lot of gas fees because essentially the first half of the whole process is off-chain, and so it doesn't cost any gas. Um, Whereas before you would have to uh, put this on chain and it would cost gas. The downside of the off chain at this moment is that it's still in a research phase, and we haven't completely worked out all of the kinks with how this works.
Seems promising.
So so here's just the diagrams which show the control flow of the scheduled transaction. The only important part here is the time node in the bottom right corner. So when it sends the execution transaction, uh, it gets paid back the bounty payout. Um, and yeah, so when the time node, because of this reason that it gets paid out, the bounty payout, the time nodes will all compete to send these transactions, to send the execute transaction, or before the execute, even to send a claim transaction. But because only one time node can actually get their transaction in, and the way that this transaction is picked is that it's the first transaction to be mined in a block. Uh, we see this problem emerge where all 5 of these time nodes will attempt to do the same thing, but only one of them gets lucky and gets to actually claim this transaction, while
So
the
this
other
is what's
4.
called a collision, right?
Yeah, so this is what we're calling a transaction collision. It's also referred to as front running sometimes, or a race condition. So yeah, so the all 5 of these transactions collide. Only one of them is successful, and the other 4 fail. And what does this cause to the network? So it means that 4 of these time nodes will have to pay because they sent a transaction which reverted, and that costs gas on Ethereum, while one of these time nodes will get rewarded in the end. So these are just example numbers, but it illustrates the idea that there's a higher loss than a profit among the entire network. So assuming that a time node gets lucky one out of every 5 times, it will lose 0.05 ether, and it'll only gain back 0.03. So what this means is that time nodes aren't being profitable, and this is a problem. And this is one of the key problems that we're solving in Chronos. So I'll talk about some of the ways to design solutions to this and how execution markets, the properties to keep in mind to create a profitable execution market. So we have 3 key topics. We have the incentivization. So the executor requires some kind of incentive to send these transactions. They can be bounty payouts, or they can be something like new user onboarding, something that is more intangible. Then we have the communication problem, which is the way to communicate your transaction to the client that will actually execute that transaction. And then we have the coordination problem, which is once the executors have the information, how can they coordinate to make sure that only one of them is sending the transaction and that the majority of them don't lose money. So the incentivization is more or less straightforward. So without a way to incentivize these people to execute your transactions, they simply won't do it. So as we've seen in some of our economic modeling, we see that there's a base cost that a time node has to make to be operated profitably. So we kind of tag this to the cost that how much it costs to run a Heroku instance every month, which is $7. So there needs to be at least $7 of bounty payments going through the network to incentivize one time node to run. And then you can kind of extrapolate and base off of that how much value is in the network to how many time nodes will be profitable.
Could the network potentially run with one time node? That's what one of the community members asked, if there has to be a minimum amount of time nodes.
So the interesting thing is that so yes, the network could run with one time node. The network could also at some point have 0 time nodes. But the interesting thing about that is that if there is a point when there's 0 time nodes, all that it takes to incentivize a time node would be a bounty payment of $7. So if you wanted your transaction scheduled and for some reason there's no volume on the EAC, you would put a $7 bounty, and then because that would mean a time node is profitable, a time node will see that and start running again. And so
Right.
it's an interesting way to kind of like bootstrap the decentralized network. And on the other end, and if there's a lot of volume, so if there's like $1 million in volume, but there's only one time node, this time node will be ultra profitable. And other time nodes will see that and they'll join in the network because they want to join in and get their piece of the profit as well. So you'll see a greater amount of time nodes joining to split
Yeah.
the transactions.
It's a true marketplace where people's transactions will be executed at the appropriate time. It's more likely that will happen if there are more time nodes to compete.
Yes, yes, and then the incentives encourage the competition between the time nodes as well.
Right.
Cool. And then so among execution markets in general, we need a way to communicate from the user to the executor the transaction that will be executed. So in the Ethereum alarm clock, we do this by deploying a contract and having the time nodes watch for every time a new contract is deployed. In Chronos, we modified this a little bit to just follow the events. So it still uses the Ethereum blockchain for the communication layer, but instead of watching for the new contracts, the time node just subscribes to every time a new event is uh, logged from a contract that we're calling the event emitter. So this contract, its only purpose is to send new events every time someone schedules a transaction, and that way the time nodes only have to subscribe to this one data feed, essentially. But going forward, there's a lot of interesting ways to communicate that doesn't involve using the Ethereum blockchain, because even sending events, it doesn't cost a lot of gas, but it does cost some gas. And so if we can optimize that gas away, it would likely be worth it on a long term because those costs add up. And also for the off-chain Chronos, there's no way to send events because all the scheduling is done off-chain. So it wouldn't make sense to schedule off-chain and then send a transaction on-chain just to communicate with the time nodes. So we are looking into other communication avenues. These can be anything, basically anything, any way to get a message from one person to another. So of course there's more decentralized options like a gossip network, so libp2p, or Whisper. These are both two decentralized ways, but there's also the centralized ways that could potentially work just as well. And the kind of sarcastic one I have here is Facebook Messenger and Twitter, but in some cases that might work. So I put them there just to include. And then we have the final kind of problem here is once we get the message to the executors, to the time nodes, how do we coordinate these time nodes so that only one of them send the transaction? And how can we incentivize these time nodes to actually maintain this coordination so that the network is net profitable and doesn't lead to a net loss? So there's kind of two ways to do this, on-chain and off-chain. And there's also the centralized or decentralized. So the centralized way to do it is, um, we know how to do that basically, but we don't care about the centralized way to do it because we want to have a decentralized network. And once we start considering the decentralized network, we get into a lot of stickier problems. But I'll go into one of the solutions that we've come up with, and this is an on-chain solution. And this is the current claiming mechanism for Chronos, on-chain Chronos. So the idea is that the time node stakes an amount of ether or a token, and when they stake, they declare some of the preferences for the transactions that they will claim, such as the minimum bounty or the how far in the future the execution window is. And then every time a new transaction is scheduled with these preferences, the time node with the highest bounty will get assigned to this transaction. So it kind of protects the time node because they get to say how long in the future they're willing to accept this transaction and how much bounty they'll get paid. And then the user knows that if there's a queue, one of the time nodes will get assigned to it. So they get kind of the insurance that their transaction will be executed as well. So we don't look at this as a perfect solution yet, but it's one solution, and we're looking at ways to optimize this and to get closer to what we think would be the best solution. And then off-chain coordination is kind of the stuff that we're looking into presently. Our first thoughts are that it's a hard problem. Essentially, a lot of the same properties of the time node execution market, being a permissionless, decentralized, trustless network, are similar to a blockchain. So our first kind of thoughts are that it might require a whole blockchain to pull off a consensus between these decentralized nodes. That's a lot of work, and we're already building off one blockchain. So we're kind of looking into ways to come for the time nodes to come to consensus without using a whole blockchain. Yeah, so that's about it for my talk. There's a few links, and we can round off with Q&A.
Great. Yeah, great job, Logan. It just shows the potential that all the development that ChronoLogic's doing now with these time node execution clients can be used for so many other applications as we see blockchain and crypto go to these evolving to these next stages of development. So
Yep.
any questions from the community? Okay, well, I really appreciate everyone coming out and listening today, and encourage you to get on and run your own time nodes in the Kovan test network and gear up for the main net when you will be able to earn ETH. We do have one question, Logan. Would time nodes be able to talk to each other, or at least to be aware of each other?
Yes, so this goes into kind of the coordination point. So ideally, there's a way for time nodes to talk to each other, whether this is a peer-to-peer kind of gossip network similar to like Ethereum nodes, for instance, or if it's some other consensus algorithm that we're using. But essentially,
Are there
yes.
downsides to, such as, people grouping together and forming pools and that sort of thing?
I mean, that's one area that we're looking into. There's definitely trade-offs under that kind of model where
Right.
there's kind of it's a decentralized network of semi-centralized nodes.
Yeah.
Um,
Yeah, you can
so
see that Ethereum is really, balancing as is coming up with these scaling solutions of how to keep it centralized, keep it decentralized, and there are certain trade-offs along the way. Okay, great. Well, we look forward to more research and development on this, so keep an eye on our blog and the live streams to learn more. Thank you, Logan, and good luck at DappCon this week.
cool. Thanks, guys.